Hey everyone, welcome back. We're here for the final talk of the day, so I'm really looking forward to this one. This is going to be Best Friends Forever with Backends for Frontends by Alix, and I'll let Alix introduce herself.
Thank you. Hi everyone. I'm here to chat to you about why I am Best Friends Forever with Backends for Frontends. So my name is Alix Klingenberg. I'm a software developer. I'm currently working as a tech lead at a pretty cool little Wellington startup called Sharesies. I started out in the tech industry quite a few years ago now as a mobile developer. So the genesis of this talk was really, as a mobile developer, trying to build a mobile application that consumed a RESTful API. And that 1 minute 30 load time for the first screen just absolutely killing me. So, I've definitely seen the worst of what APIs can look like in some ways. These days, I'm mostly a C# developer. I must warn you now, there will be some C# in this presentation. I'm sorry, I promise it won't be too much. In general, what I'm going to try and talk about is things at a really conceptual level. What I really want to communicate is the framing for how I think about API design and the way that that influences the choices I make. So hopefully, if you take anything away from this talk, it is maybe a shift to your paradigm, a shift to your framing, or just some other concepts to think about when you're making decisions about what to build. So here's a little roadmap of our talk. The first thing we're going to discuss is what I mean by the concept backend for frontends. After that, I'm going to talk about my BFFs, the backend for frontends that I've been best friends with. And then I'm going to talk you through a little bit more of that implementation detail. And that's where I really want to dive into the part where I think you weigh your choices about how you design your APIs, about what goes where, about what becomes an endpoint, what becomes a different class, and so on. So to start off, let's talk about the term backends for frontends. In general, I would call it a sensibility, right? In general, whenever we think about things in tech, we apply a framing to it. Backends for frontends is a sensibility to how you might design your APIs. So it's technology agnostic. You can use it with a RESTful API. It doesn't mean that you use, JSON over HTTPC. You could use RPC. I will say I do not think it is compatible with kind of the goals of REST. Does anyone want me to explain what I mean when I'm talking about REST? I'm going to do it real quickly anyway. My understanding is you have your business domain, and REST is a set of APIs that allow you to access the different kind of models or objects in that domain, and it's fairly reliant on HTTP methods to determine what you are doing with those models, so whether you're getting them, whether you're updating them, and so on. That might be a really horrible explanation. We can fight about it in the question time afterwards if you want, that's fine. In general, what I want to get across is the BFF idea is that you have an API per client experience. And those words, client experience, are chosen very carefully. What I mean by a client experience is that technology is consumed across a billion different types of devices in a billion different ways. And we design our technology, we design our applications to be used on different tools. So, the really rough version of this might be mobile versus desktop web. In general, I think that there's a really interesting question here when we talk about client experience, where you get to pick your own adventure. And what I mean by that is you get to decide the granularity of what that means for you, what that means for your existing application, for your business domain, and for your goals for your application is going to go. I'm also going to talk a little bit about microservices in here. Haha, I bet you didn't expect that. So one concept that I think applies to both BFFs and microservices is this idea of right-sizing. Right? So it's kind of a spectrum. You might have a billion different microservices that all interact with each other. Or you might have really chunky microservices, and you've got 3 or 4 of them. When we talk about right-sizing, we mean the right size that is suitable for your technology, that is suitable for your goals, that's suitable for the tooling and things that you have there. So again, I think that granularity really depends on what you're trying to achieve, what the size of your team is, what the size of your application is, right? So in general, this is not prescriptive about, any particular size or anything like that. When I say sensibility, I think that when we talk about BFFs, it's just to frame up how we decide what lives where and what does what. So the idea of BFF, I first heard of it from this Australian developer guy called Sam Newman, who writes quite a little bit about microservices, about security, about BFFs. And so, yeah, he shared some of the experiences that he'd had, I think, working with a company called SoundCloud. And that's sort of how I came across this idea. So SoundCloud actually published this really cool article. And brief digression, because I'm the one with the mic and I get to tell you my funny stories. If you're extremely online like I am, if you're on Twitter a lot, you might know that if someone makes a popular tweet and lots of people like it and interact with it, they have a tendency to follow up with from their own popular tweet by saying, hey, go to my SoundCloud, where they might host their music and might get money for it. This deeply annoyed me, so I muted the word SoundCloud on Twitter, and so I missed out on this whole thing for quite a while. Because Twitter is where I get a lot of my, stretching technical ideas and so on. And so anyway, I love this diagram. It's got everything. It's got boxes, it's got arrows, it's got colors. But what's really interesting is the way that they have represented the BFFs layer. And you can see how it's in multiple discrete layers. Implied by the size of those layers is actually that it can be quite a thin client, right? So much like choosing how many things are in your BFF, you can also kind of choose the depth of it, right? You can choose how much logic is in there, how much complexity is there. A former colleague built a GraphQL layer that was just a very thin layer over multiple microservices. And this is sort of what we can see here, right? You can see that they've got a whole lot of microservices, and they're kind of aggregating them up into these BFF layers. And you can also see that they've got their big chunky monolith, because most of us have one of those hiding up in the attic somewhere in our code base. The other thing that I really like about this is you can see the granularity that they've chosen, right? So you can see that there are 2 Android applications. And this is where the client experience idea comes in. You can see that they've decided that their iOS and Android applications, the general consumer-facing ones, are similar enough that one API serves them both. But they have another Android application, and that one is used by people who are creating, not people who are consuming. And so they've built a separate API for that, because that client experience is significantly different. And I'm going to talk you through why I think this is a good idea a little bit later. But one of the other things that I think is really interesting is you can also see that they actually have a Sonos integration here, right? So Sonos is hardware that plays music. What is relevant here is that the client experience doesn't have to directly speak to a front end. It is just that. It's an experience. It doesn't have to be tied to a UI. So yeah, I think this is a super cool diagram. And yeah, what I'm speaking about here, you might notice as well, is that all of these experiences, aside from maybe the Sonos, in general are experiences that are owned by the organization, right? So I don't think that a BFF in general is what you want if you want to expose a general purpose API. For example, I've played around with GitHub's API quite a lot. They have a GraphQL API. That's wonderful. They just want to expose a range of things. Here, I'm thinking about the particular client experience that you're trying to create, right? We're not trying to solve the general purpose case. So here are a few of the reasons that I think BFFs are pretty freaking cool. Unfortunately, I can't read my own slides, which means that this is going to make my life hard. Essentially, one of the reasons that people like microservices is that it provides a logical boundary for things. And again, this right-sizing thing is up to you. I'm not trying to be prescriptive about what goes in a microservice. But when you have a single logical unit that is also a discrete deployable unit, that means that you get some quite nice benefits around how a team works on it. right? So you can actually have really good outcomes around ownership, around your APIs, much like you get those same outcomes when we choose to go to microservices as we scale up our teams. So this works really, really well. Reading off my slides again, releases are easy. Basically because you know what your client experience is. You know what your consumers are. You can actually have quite a bit of certainty around the impact that your changes will make because you know exactly where they're going. So you don't have to test a breadth of things, and you don't have to have complex testing diagrams because you know what is going to be affected by these changes. So you know when you need to release two things in tandem and so on. The other thing that's really cool is caching decisions become quite good, right? So you get some really nice caching when you know that there will be a certain type of traffic at a certain type of time, you know what data you're going to need, right? So you can get some really good gains on speed, which is a really nice client experience. So again, this is about that framing, right? This is about thinking about your APIs and framing your APIs as a decision about client experience, which in the end is about your user experience. So this is kind of a tool that I think is really great for thinking about how your API decisions are going to impact your users. Man, I'm going to see if I can mess around with my slides a bit. Oh, look at that. I did a thing with the computers. I'm so proud of myself. So yeah, as I was talking before, I had a friend who was working at a fairly large company here in New Zealand, and he was telling me how he built a GraphQL layer on top of their monolith. And what was really amazing about this was the company was moving towards microservices. And like many sensible larger companies, they were peeling away bits of the monolith and spinning up new things as microservices as it made sense to do so. Having this nice GraphQL layer meant that they could change these microservices underneath without actually changing anything about the client experience, right? So having these kind of options does allow you I guess, to get some of the benefits of an API on both sides, right? You can imagine that the API boundary is both a static API on both sides, which means that you can kind of change things without impacting other bits and pieces, which can, be really nice, both for moving to, moving to microservices or just serving as a transition. Cool. So I want to change tack a little bit and talk to you about some of my BFFs. So my previous job, I was working as a software engineer up in Auckland at a company called Aura. And they're a relatively small New Zealand-based product startup. And I actually followed my boss from my previous job there. And that was because he had this really exciting opportunity, which was this company is successful. They have a really awesome product. Their problem is that they cannot release features fast enough because they've never really had in-house devs. They've had a series of contractors with very different ideas about how to do things, and their code base is very resistant to change. So come join me, and we're going to sit down and we're going to implement the whole thing again from scratch in 6 months. And obviously I was like, oh yeah, okay, cool, I'm sold. We're done. And so this is where I first sort of started actually using the BFF kind of sensibility in practice. So when I say did I mention we did a rewrite, the very first time I gave this talk, my boss was in the room, at the conference talking about how we decided to do a rewrite, which was great. It's really awkward when audience literally has to pick between you and your boss, and you kind of want to get more people, but you also don't. That was awkward as hell. So for us, it was a relatively unusual, experience in that generally, we all are sold on the benefits of CI/CD, of deploying frequently, of getting our changes out as often as we can. For us, we were certainly doing continuous integration, but the thing was, we really needed speed and we needed flexibility because we wanted to build things as fast as we could, but we also knew that we didn't know everything up front, and trying to know everything up front was not going to cut it. So those two things, the speed and flexibility, were why we chose this approach, because it kind of gave us those things. And the other quite interesting thing about their technology was they had 3 really distinct client experiences. So they had a desktop web application that was usually used by people sitting at their desks. They might spend an hour or two interacting with the website. There was a mobile application that was used by people who were on a shop floor who had a billion other things to do, but needed to get some data quick, needed alerts. And the final one was a desktop application that was operating in a deeply resource-constrained environment, both network and CPU constraints, that also had to send out alerts based on optical character recognition, so reading license plates. So that thing was busy as heck, and also needed to get updates through fairly frequently. So with these really distinct differences, it didn't make sense for us to try and build, an API for what we'd want later, or an API that we thought could be really usable. We split it out very clearly. And yeah, we chose this for those two things. And I'm going to talk a little bit later on, when I talk more granularly about implementation, about how we got that speed of development and how we got that flexibility. So current job is at Sharesies here in Wellington. Sharesies has what I like to call macro services. It's like a big chunky service. We've got about 5 of them, I think. The thing that I find really interesting about Sharesies is I don't think that we really do BFFs as such. We certainly have custom APIs, but I would say that in general, sometimes our APIs are used by multiple clients, which I would say is not really part of the BFF sensibility. But as opposed to Aura, where we really cared about the quality of those different client experiences, at Sharesies, the distinction, the thing that we really care about based on our sort of business domain, is the different types of traffic, right? And the reliability and kind of the segregation of those types of traffic. So what I mean by that is Sharesies does, you can buy shares on it, basically. We treat traffic where you are making a share order, a buy or sell order, somewhat differently from traffic where you are changing your email or adding something to your watch list, right? And that is not just because of regulatory obligations, although another feature of my career has absolutely been working in very heavily regulated things like Happy to Talk, HIPAA, PCI, all the horrible acronyms. But in general, for us, BFFs aren't as important because our client experience is generally the same. And so our focus here is on more internal kind of reliability and segregation of those things versus supporting multiple different things. But letting you in on a little secret, and please don't share this, we might be having a mobile app real soon. So we'll see how that goes. And so anyway, I guess what I'm trying to share there is this is how I apply that thinking to the different business domains, right? Like what is right for the domain? How am I trying to prioritize the client experience here, and where is this kind of framework appropriate versus where is it not really going to capture the things that are important to the business? So, this cool idea. Yeah, prioritize client experience. Sounds great. Obviously, we want to do that. The trade-off that people are probably thinking about is a lot of client experiences do have a lot of things the same. They do share a lot of log-in, log-out functionality. They do share a whole lot of CRUD operations, right? That's all it is underneath, and that's how we get REST APIs. But the fear about duplication, I think, is sometimes a fairly surface-level fear. It's something that we consider a code smell and that we try to avoid. So I kind of want to dig into where duplication can be good and where duplication is bad, and how we can think about those different options. So yeah, I will say as well, I mentioned that the BFF approach, it can just be a thin layer. Theoretically, there is no implication on duplication or loss of reusability or anything like that. But in general, we all know that best intentions, your business logic finds a way into everything it touches. So maybe you all are good at that, but my stuff definitely does. Okay, so duplication smells nasty and yucky and we hate it. Developers look at these things, they think this looks like this other thing, let's smash them together, and now we only have one thing, right? Why do we do that? Bugs are kind of a big thing here. So there are 2 classes where this duplication goes wrong in the case of bugs. One is that there is a bug in this piece of code that someone has copy-pasted somewhere else that you don't know about. So you fix the bug in one place and the bug persists elsewhere. This is very annoying, bad user experience, and you get so frustrated. I thought I fixed that. That's fair. There's another kind of case as well. And I'm going to dig into this a little bit later in the theory of connaissance. The other case is where you have two pieces of code that are actually doing the same thing. They're not copy-pasted, but you want them to live together because you don't want them to do the thing differently. That is because they have the same algorithm, essentially. They share the same concerns, they're making the same decisions, right? It is the same piece of logic. And that kind of duplication is a little harder to detect, and it is one of the key reasons that developers kind of go, nope, we're going to put that all together and keep it nice and close. So when we have a code base that has a lot of duplication, aside from the bugs, the other poor effect is that we lose our development speed and we lose flexibility in a code base. And the way that this happens, I like to talk about code base viscosity here. So the idea is that a code base that is quite viscous is one that is resistant to change. Where resistance to change looks a whole lot like taking a long time to make changes. To do something, you have to touch things in a lot of separate places that maybe don't feel related to you. Maybe it's really brittle. Maybe you have to remember a whole lot of steps. In general, this kind of code base is, this is what we say, resistant to change. Changes are difficult, they result in bugs, they have more mental overhead than a nice, tidy code base where you can change the thing and the place and then it just works. And so this is why we avoid duplication, and these are all very good reasons. On the other hand, I think that one of the benefits of duplication is that it is cheaper than the wrong abstraction. And I'm going to say that one again because it's like my favorite thing. Duplication is cheaper than the wrong abstraction. When we talk about abstractions in code, in general, all code is an abstraction over a real thing. An abstraction is by nature an imperfect copy. It is an imperfect map, right? The map is not the land. There are always going to be leaky bits and pieces. And the thing with a bad abstraction is that it causes very subtle bugs. The bugs from having copied code and having to update things in more than one place, those bugs are really freaking annoying, but we have tools for managing it. Understanding that something works a little bit differently, even though you've kind of lumped these things together, that's really expensive to undo, and it requires a lot more thinking, because a lot of the truth of the actual model of that thing is elided from you when you're just looking at the abstraction. So you also get this flexibility, right? So when you duplicate, when you say, okay, I'm going to have an API for my mobile and an API for my web, and they're both going to log in and log out. Maybe it turns out that you want to use a different type of authentication. Maybe there is something that you're going to change. So the benefits of this duplication is that it gives you protection against future changes. It's that flexibility that you really want, where you're not assuming things are the same and then abstracting it out, having to pull everything apart before you can make the changes takes longer. So that flexibility is pretty nice, and it's one of the things that, as I mentioned before, in some cases is the thing that you want to prioritize. Okay, can take a wee break while you all look up what connaissance is. So connaissance, I encountered this when I was like a grad, and I had no fucking idea what, sorry, not me to swear, no idea what it meant. I went to this talk at CodeMania by a guy called Josh Robb, who was the VP of engineering at PushPay when I was there. And it was an incredible talk because I lasted about 20 minutes into it before I stopped understanding anything. But it sounded really interesting to me. And so I've spent a little bit of time thinking about connaissance theory. So connaissance is essentially a way of thinking about a dependency relationship. And when we're talking about code duplication, I think a lot of that is kind of a dependency relationship. We can talk about connaissance of two objects where two things are connaissant if changing one requires changing the other. So the useful thing about connaissance theory is that we can think about it in terms of stronger to weaker degrees. So a weak connaissance, for example, is a variable name. If you change the variable name in one place, you have to change it in another, right? Otherwise your code's going to break because it does. Your compiler doesn't know what that thing is. Oh, sorry, I forgot you guys don't have compilers. Transpiler. Okay. So the thing about that sort of weak type of connaissance is that our IDEs handle that for us, right? We get the lovely red squiggly. You actually get that kind of right time certainty. The stronger degrees of connaissance are the ones that are harder to actually mitigate. And so remember, if the concept of connaissance is that if one thing changes, this other thing that has a dependency on it also has to change. So I think the first bug I ever fixed when I worked at PushPay was that people would sign up with an email, and that was fine and valid. And then when they went to log in, they would be told that their email did not exist. I'm sure everyone has had a similar kind of bug at some point in their career. The problem was casing. So one side was case sensitive and one side was not. That is connaissance of algorithm. And that is where we had implemented an algorithm at one point that that had certain thoughts about how something worked, what was valid, and we had an algorithm implemented elsewhere that had a different opinion. And that kind of bug is really subtle, and it's harder to fix, right? So that's what we consider a strong degree of connaissance. We need those things to be the same, but we don't have tooling in our IDE to tell us, hey, these two things are the same. And this is kind of the fear of duplication, right? That we're going to hit that kind of strong degree of connaissance. The thing with connaissances as well is that you can actually change the degree of connaissance. You can move things down. So one example is you have the same algorithm in two places. What do? You extract a function. Now you call the same function and you have a connaissance of name. So you do actually have the ability to change the degree of connaissance. In general, I consider this kind of duplication to be one where you can't really get around it sometimes. The canonical example is client-side validation versus server-side validation. We all know you never trust the client-side validation, but you still want that there for your user, to give your user, that kind of immediate feedback that they need, because we're all about great user experiences, right? So when you are thinking about things that are duplicated, no, don't you turn off. When you think about things that are duplicated, you want to think about ways that you can move it down to a weaker connaissance. In some cases, if you have a BFF and you have things duplicated, I highly advocate for leaving them there for a while before you abstract out perhaps a microservice or something else. Because of what I was talking about before, because the abstraction is leaky and harder to unpick. So in general, I think that the kind of ugliness of duplication is in some ways more important when it's there. So yes, this talk is absolutely just a collection of ideas by smarter people that I'm just sharing my experience with, trying to implement. But I really love this tweet. Essentially what he's saying is that, I highly recommend getting your code reviewed by other people, but sometimes you have that moment where you've written some code and you've been like, oh, this is so annoying, let me just get it out. And someone comes along and they say something that is so blindingly obvious, you can't believe you didn't think of it. And maybe it's been because you've been sitting in that problem too long. But I think that there is a lot of value, especially in terms of connaissance and of thinking about these dependency relationships, where the ugliness is obvious. So if you have BFFs, if you know that all of your BFFs have their own implementation of how, of how login works, of how logging works, or whatever, if you know that that's there, if you have that visibility of it, it allows you to have the flexibility to change it when you need to, or to make the right abstraction when you also really need to do it, right? So try and make this duplication obvious. Don't try and reuse things for the sake of reuse. So yeah, I really love this idea of you kind of have to have the bad, ugly code there sometimes to be able to see the right abstraction. Because otherwise, if it's already abstracted away, you lose the full context because that abstraction is a simplification. Right, that was intense. Maybe duplication's not that bad. One thing that Sam Newman says in the blog post that I read that I really liked was try to reduce duplication within a process boundary. And I think that's a really useful way of thinking about it, right? Within a process boundary, you can reduce the duplication because that is all very nicely constrained. In general, if you can, make it obvious. Make it something that you know about, and don't try and prematurely optimize. Cool. So I want to talk about some of the super cool stuff that you can do when you have an API that is specifically for that one client experience, right? There are a wealth of tools available. Swagger allows you to generate, API, generate TypeScript out of it. You can have a model designed for a particular view or an element, right? If you're writing in React, you can have an endpoint that is designed specifically for that React component that gives it everything it needs. And you can just straight up generate the TypeScript definition of that. The validation side is actually really interesting. I've definitely had a problem in the past where I have changed things on the server side, have completely forgotten that the front end exists. I'm sorry, please forgive me. And I broke things. And in general, this is where I like to think about. Sarah gave a great talk about blamelessness before, right? Fix the process. Don't say, "Wow, Alex, you should have remembered to regenerate your models and look at all the places that thing changed and things broke." Fix the process. So this is a beautiful way that you can actually add some certainty, some validation into your models so that you get some info about breaking changes. Someone who was reading my slides over my shoulder was like, it's not a talk without a Gary Bernhardt tweet, and they were right. Gary Bernhardt is a computer scientist. He's a super smart guy. Essentially, what he's saying here is, why can I not have this kind of verification that these two things that have this dependency relationship actually can talk to each other? And I do find with the BFFs approach, it's quite easy to do that. So here's the C# I warned you all about. Essentially, what this is doing is taking a diff of your API. Or it's actually just generating your API at this point. It's a terrible method name, forgive me. .NET has some gorgeous introspection points that allow you to reflect over your code and figure out what your API actually looks like. If you want to, you can dump that out into some JSON that your TypeScript can read. You can make this part of your build process. So you can actually say, hey, has this changed? I'm going to throw up an error to the developer. Or if you want to, you can actually hook in and do some really cool things. So while I was reading about this stuff, Spotify. No, maybe, oh my God, I've forgotten who it was. Anyway, so Spotify, I think, was doing some really cool stuff. They were using RPC. Shall I explain RPC? All right, RPC is remote procedure call. So when we think about an API, in general, an API is, like a REST API is structured around your models and so on. The idea of RPC is it's a way for machines to call another machine and tell it about, invoke a process. What's very cool about it is that it involves generated clients. So the generated client will sit on either machine, and it shares a binary format that it uses to encode messages. So no JSON, nothing like that. It's a very quick way of machine-to-machine communication with these kind of generated clients. gRPC is Google's version of it that I think is getting quite good adoption. Obviously, one of the downsides of this is that it is harder to introspect. You can't look at the JSON to figure out that one of your properties is missing or whatever. But anyway, Spotify or whoever were doing this really cool thing where they were actually generating their clients with all of the logging, all of the metrics, like a whole host of quite cool things that you might often put in like a sidecar service if you're doing like microservices. And they were actually just putting it in their client so that they had a whole lot of information about how their endpoints were getting called. And again, with BFFs, you can very much do something like this when you hook into understanding what your API looks like. At this point, you can just arbitrarily add whatever you want if you're OK with, constructing Java and C#, which is totally fine and normal. So this is the generate clients part. What's quite cool here is you can see that it's getting serialized to JSON. I'm using an ascent library that I really love. Docs are terrible, but that's OK. You really only use it one way, and that is you give it an object. And what it does is it takes that object and it serializes it for you, and it creates a file that you then check into Git. And you can also give it an arbitrary string. And this sits inside a test. And what happens is whenever that test runs, it generates the object again, compares it against its existing one, and if it has changed, it gives your developer a warning. Like, hey, I see you've done a database migration, but you haven't updated the clients. So it's an incredible way at unit testing time as part of your build pipeline to actually communicate these things, to communicate the breaking changes at the time that you are writing them. And this library in particular is really nice because it pauses the test, it pops up whatever diff tool you have configured in Git and says, would you like to accept this set of changes? And you can sort of give it a server-side mode where obviously it's not going to do that because it's running headlessly. But it's a really nice way to kind of prompt the developer to think about these changes that they're making that we know matter because we know exactly what format our clients are going to expect because we built an API specifically for them. So yeah, in general, this is, I guess, the thing that I am aiming for here is flexibility, right? This talk has been about my priority of developing things that are frequently changing, that are frequently being developed by other people. That might not be your situation, and that's absolutely fine. But for me, I prioritize flexibility. I think in terms of connaissance. Where can I take something that is hidden and ugly and make it really obvious? Where can I add tooling and processes to let people know when something changes that will break? The other thing that I think about this talk as well is, in general, I suspect a lot of this stuff is stuff that people do, right? This is things that you all kind of think about anyway. And so, the first time I gave this talk, the first question was, this person put up their hand, they were like, this sounds really great, but how do you get your team on board with this? And my answer was to point at my colleague in the front row and go, you get up on the stage and you tell everyone else about it, so then your colleague feels weird disagreeing with you. But in general, I think that this kind of development makes a lot of sense, but having the language and the ideas around how to talk about the trade-offs that you're making, how to talk about what you're prioritizing, and how to make the ugliness obvious. Those things aren't always easy, and we always want to do the best. And sometimes for us, leaving ugliness on the surface is a bit awkward. So yeah, hopefully this is an interesting frame to share. If you have any questions, let me know. If you go to this link, you can book in half an hour with me. We'll have a little chat. It'll be great. But yeah, thank you all.
So if you have any questions, can you raise your hands and I'll bring you the mic.
Hey, what's the antonym of BFF?
Oh, I think it's frenemy. The antonym of BFF, that's such a cool question. I think general purpose APIs and RESTful APIs in general are the antonym here, right? Where you're trying to build something that is generally applicable rather than prioritized for that specific kind of thing. Yeah.
Other questions?
Hi, thanks for the talk. One of the kind of controversial aspects of talking about BFFs, particularly with different types of technologies, is one that I particularly like with GraphQL. Can it be the single BFF to rule them all, and so that you don't have to build out different servers? I know some of the SoundCloud people have different opinions on it, and I'd be interested in yours.
My expectation of GraphQL is, I almost think of it more in that general purpose sense. When you have to build something that can be so widely used, then it's worth the investment. I think that, as I mentioned, one of my priorities here was speed and flexibility, and I think that building out good GraphQL support becomes very complex and very heavy. And so that's where I think the BFF approach really shines, in that you are prioritizing for that particular client experience. Yeah. Oh.
Hi, I'd like to talk. So you said, when you are making an extraction, you might make that into like a service or something. Is that then a BFF for the BFF, or how does that actually practically happen?
I'm so sorry, I didn't quite catch the first part of your question.
That's all good. So you said when you have similar things that are similar and you want to abstract them, are those BFFs for BFFs themselves? Like, how do you construct and architect that without like having a billion different services?
That's a great question. I think it gets answered on several levels. One was the comment from Sam Newman's blog around reduced duplication within a process boundary, right? So I quite like that concept because it's not saying within a particular repo, because we all know that doesn't mean shit in terms of what is actually what your deployable unit is or what's used. So I think, reduced duplication within a process boundary. It also comes back to the point about right-sized microservices. So if you do have a whole lot of, a proliferation of microservices and the ability to support them, maybe it does make sense to start thinking about abstracting things out there. I think another option can always be a shared library. I'm hesitant to suggest it because that's got so much overhead of support and creation, and it isn't generally the way that I would go. I think for me, it partially depends on the complexity of what is shared, how difficult it would be to pull it out, and also partially, how bad it will be. What is the cost of this being slightly wrong or slightly different? All of these things, I guess, I'm quite comfortable with leaving that duplication there for quite a long time, unless I think the cost is going to be particularly high. And the cost might be high in microservice proliferation. The cost might be high in the impact of it being wrong. All these things. I think those. You've kind of hit on the thesis of this talk, right? Which is these are the series of factors that you have to take into consideration when you do decide to duplicate or deduplicate. Yeah.
Thank you. Very interesting talk. My question is basically, how do you measure the impact BFF makes on the client and how significant it is?
That's a great question. I guess it partially depends where you are looking to do optimization, right? So I haven't done a whole lot of I guess, measurement in general. One thing that I've found particularly useful about BFF was being able to tie particular, I guess, heavy database queries to particular calls that were happening. I guess it depends, if you are going to profile your entire application, at least you know where things are working, and once you profile, you can figure out where to, was there? Did that answer your question? I feel like it didn't.
I meant mostly like performance, impact on the performance in terms of the requests from the client to the server, because this is an additional layer between the API. So how significant is the impact, basically?
Yeah, great question. Right. Yes, excellent trade-off. And I think someone else asked an excellent question about GraphQL as well. And I think one of the pain points of GraphQL can sometimes be that if GraphQL is put as a layer there that is an aggregator, you are actually, it sometimes ends up being quite a blocker. I think, again, it depends how thick your BFF layer is. And again, it also depends on what your services behind it look like. In general, when I have designed them, I showed some C# code. In general, the way that I do it is just at the controller layer in C#. So rather than an entirely separate deployable unit, it's just a separate package within, within a larger repository. I think that definitely if you are making it, it is useful as perhaps taking that performance hit if it is part of a wider strategy to change things in the background, right? So when I talked about like carving off microservices, and breaking up the monolith, I think that sitting with the ugliness for a while, if it is, while you're changing stuff, I think that's kind of where it really shines, aggregating while a whole lot of change is going on in the background. Cool.
Great talk. I really enjoyed it. I have some experience with BFFs from working in a very large company, and we probably had a very similar model to what you showed with Spotify, where we had lots of microservices, and then each client will actually build their own BFFs. So we had teams, like client-side teams, or even you had like a web app and then have multiple teams working on the web app, working on different parts of the web app, and each team will build their own BFF to communicate to all these microservices. So for us, this was like a way to give these teams full ownership over their area of the product, and it made sense that they own the BFF. So how does it work in a smaller company? Like who owns the BFF, and how are the teams organized around clients and BFFs?
To speak to my own experience, at Aura, the team was small enough that, in general, I guess everyone owned it, right? We kind of shared ownership of it. If something went wrong, it went to whoever was most familiar with that feature, whoever touched it last, basically. I think, in general, again, it depends how thick the BFF is, right? Like how much logic lives there, and what your team is made up of. I guess I tend to think of it as being tied to that client, but working in collaboration with the teams who own the rest. One of the discussions that we're having internally at the moment is what does good service ownership look like? And one of my colleagues shared this really interesting concept around anchorship, where you don't actually own a service. A team anchors that service. And when we say anchor, what we mean is they might build, some of the tooling around it, some of the improvements, and they kind of own the future of it, right? So they have this idealized vision. Maybe it's, pulling this part out and putting this thing in. And I think that kind of anchorship model becomes really interesting in questions like this, where that BFF team, that client API team, is really reliant on the teams behind them in order to actually get something that is quite performant and have access to the things that are good. And so I think that model where the team is able to own it, but they can also contribute to the other upstream services, downstream services, I can never remember which way it goes, in order to push those outcomes. For me, that kind of highly collaborative model is the easiest. But yeah, my experience is definitely in the smaller side of companies. Cool.
Any other questions? Excellent. Can we all give a big round of applause to Alix?